Hello, everyone. So this week we have started with a new lesson, which talks about the trigonometric circle or the oriented arc. In this lesson, we are going to talk about the circle, the arcs, the angles in the circle, what's the relation between the degree and the radian. Also, we're going to talk about the principal determination or the principal measure of an arc. First of all, let us remember together, this is a circle, this is the center, this is the radius OA. If you start from A and you pass through the circumference of the circle, you will be going from the positive sense if you go anti-clockwise. And you'll be going in the negative sense if you go in the clockwise sense. Uh, Let us remember together what's the meaning of a central angle. AOB is a central angle that measures 30 degrees. Then the arc AB measures 30 degrees because it's facing this central angle. So the arc is equal to the central angle that faces it. Okay? What else we need to know? We need to know that a complete circle is 360 degrees if you go in the positive sense, and it's minus 360 degrees if you go in the negative sense. From A to, suppose here we have a point F. From A to F, it's a semicircle or it's a half turn. It's not a complete turn, it's a half turn, so it's 180 degrees. And if you go in the negative sense, it will be minus 180 degrees. Let us start first. You have to know that in a circle, I have two units of measuring the angles. It's either the degree or the radian. Okay, so it's either the degree. When you talk about degrees, you start from 1 degree until you reach the 360 degrees. The radian, it's the measure of the arc whose length is equal to the radius of the circle. Okay? So the measure of the arc is equal to the radius. It's not equal to a central angle. Now, what's the relation between the degrees and the radians? So how can I change from degrees to radians and from radians to degrees? There's only one rule, which is the crisscross rule. Starting from now on, 2 pi is 360. Pi, not 3.14. When we say pi, we mean 180 degrees. Okay? So that 2 pi, it's 360 degrees. And a pi is 180 degrees. Okay? So if you look at this crisscross, what does it say? It says that 180 degrees is equal to pi. So you put this relation, if you have it in degrees, you put it in front of, instead of A, and you find B. If you have it in pi, in radians, and you need it in degrees, you put it in front of, sorry, instead of B, and you calculate A. Of course, you will not be able to understand what I'm saying unless we start measuring. Suppose I gave you that we have 30 degrees and I need it in radians. We put 30 instead of A, so 30 over 180 equals B over pi, okay? And we do a cross multiplication to know B. We do 30 times pi divide 180. So 30 times pi divided by 180 degrees. Of course, you simplify to the maximum and you get pi over 6. So every time you see 30 degrees, it's pi over 6 in reference. So there are special angles, like for example, 30 degrees, as we just calculated, it's pi over 6. 45 degrees, it's pi over 4. 60 degrees is pi over 3. 90 degrees is it's pi over 2. 180 degrees is exactly pi. 270 it's 3 pi over 2. 360 is the pi. Of course, I'm not asking you to memorize them, but they are common sense. As much as you practice, you know that you can tell them directly. Now let us do a simple exercise. If an angle measures 72 and they want it in radian, you put as I told you, the 72 instead of A, and you do a cross multiplication. 72 times pi divided by 180, it's 2 pi over 5 radians. Now, what if I have an angle that measures 5 pi over 12? I will give you a hint, which is much easier in order to calculate it in degrees. It's enough to replace the pi by 180. So you do 5 times 180 degrees divided by 12. You will get 75 degrees. Okay, so no need to use the rule. You just replace the pi by 180. Now, how can I know the length of an arc of a circle? That was the first objectives. The first objective. In this lesson, we have three objectives. We already covered the first one. Now, the second one, which is the length of an arc. If we have an arc, how can we calculate its length? It's very easy. It's one rule. The length equals r pi d over 180. What's r? It's the radius. What's d? Okay, D is the measure of the angle AOB, which is the central. Okay, so that's very easy to calculate the length. Now we will talk about the orientation of a circle. I already started in the activity in the lesson when I told you that if you start from A and you go anti-clockwise, this is a positive sense, while if you go clockwise, it's a negative sense. If you pass from A to M, this is in positive sense. But if you go like this, from A to M, this is a negative sense, okay? Now you have to know that the circle is divided into 4 parts. This is the 0. This is pi over 2. This is pi, because it's a half orientation. And then you complete, this is 3 pi over 2. And this is 2 pi. So every time you reach the 2 pi as if you started from the beginning, which is 0. So from 0 to 2 pi, you go back to the initial state. Now, how can I calculate, okay, the principal determination or the principal measure of an arc? If I tell you, for example, an arc AB, it's an oriented arc of measure 7 pi over 4. 7 pi over 4, it's of course more than one complete orientation. But suppose what I'm trying to say is this arc, okay, this arc, it already had its complete circle and a little bit more. This little bit more, how much it measures, that's what we need to calculate in order to know the principal measure or the principal determination. First of all, you know that every time you go back to the 0, you go back here, every time you do a complete orientation, which is 2 pi, it goes back to 0, and then you calculate the additional part. So look what we are going to do. 7 pi over 4, we're going to write it as 8 pi over 4 minus pi over 4. Do you agree that 8 pi over 4 minus pi over 4 is the same as 7 pi over 4? Yes, of course you agree. Now, what's 8 pi over 4? It's 2 pi. 2 pi, it gives you 0 because, as I told you above, if you do a complete orientation, which is 2 pi, it gives you the position of 0. So this is 0. What's left is minus pi over 4. This is the principal measure of. Great, let us do another example. So here we have minus 11 over 6, minus 11 pi over 6. How do I write it? Of course, I have many ways to write it. For example, I can write it minus 10 pi over 6, okay, minus pi over 6. Do you agree that this is true? Of course it's true. But if you do minus 10 pi over 6, does it give you 2 pi? No. So this is not correct. So every time you have to pay attention to write this fraction in a way, the first one gives you 2 pi and the additional part. So minus 11 pi over 6 is written as minus 12 pi plus pi over 6. And minus 12 pi over 6, it's 2 pi, which is 0. So the principal arc is pi over 6. That's if the given is using radians. What if the given is using degrees? It's very easy. You divide the measure by 360. It's 3 point something. So it's 3 times 360. So 3 complete orientations, okay, that leads you back to the 0 plus 140. So this is the principal measure. So the same thing, if you have a degree, you divide this number by 360. It's 3 point something. So it's 3 times 360 plus 140. So this is the principal measure of the arc. Okay? In this lesson, as I told you before, we have 3 objectives that are how to move from degree to radian and from radian to degree. And how can I tell the length of the arc? And how can I find the principal measure of an arc if it's more than one complete orientation, whether it's in radian or in degrees. Now we are done from chapter 10, okay? In chapter 11, we're going to talk about trigonometric lines. We're going to go back to the circle and its orientation. Let me first remind you of the things that we have learned last year, which is the trigonometric ratios in a right triangle. So you know that the trigonometric ratios, we can only use them in specifically right triangles, okay? So in right triangles, we have CB, which is the hypotenuse, which is opposite to the right angle. Here we have AB and CA. We have 3 important lines, okay, trigonometric lines, we call them, the cosine, the sine, and the tangent, and the cotangent. They are called trigonometric ratios or trigonometric lines. Suppose we want to calculate the cosine of an angle B. Cosine, it's the adjacent over the hypotenuse. What's the adjacent of angle B? It's AB. So it's AB over the hypotenuse, which is BC. So every time you need to calculate the cosine of an angle, it's the adjacent over the hypotenuse. What if you have sine? Sine, it's the opposite over the hypotenuse. What if we have tangent? The tangent is the opposite over adjacent, and the cotangent, it's the inverse of tangent, which is adjacent over opposite. Okay? I'm not going to continue more because I'm going to do another video that talks about the important properties and formulas of this lesson. I'm just reminding you of the trigonometric lines that you have already learned last year.